So we've already multiplied and divided rational expressions. Today we're going to add and subtract. Now adding and subtracting is a little trickier, right? Because we can only add and subtract if we have common denominators. Okay, so 5.3, we're going to be adding and subtracting with common denominators. Okay, so how do we do that? Step 1, we rewrite the problem so that they're all over the one common denominator. So we put the whole thing over one fraction. Step 2, we distribute the sign. So if it's addition, we distribute the sign. If it's negative, we distribute the sign. And then step 3, we combine like terms. Step 4, we factor the numerator and denominator so that we can simplify and cancel as much as possible. Okay. Example 1. Yeah. Example 1, 5 over 2m plus 4 over 2m. So what we want to do is we're going to rewrite it so they are all over the common denominator 2m. 5 plus 4. And then 5 plus 4 gives me 9 over 2m. And that's the answer.
That is like so easy.
Okay? Example 2. Okay, example 2. We have n over n plus 3 plus 2 over n plus 3. Do I have common denominators? Yes. So I'm going to rewrite the whole thing over the common denominator. And then I add the numerators, n plus 2. Now, can I combine those like terms? No. Okay, can I factor either of these? No. So guess what? That's your answer.
I thought you just said we couldn't find ones like this. You had a
place You said it was hard.
Okay, example 3. 3t over t minus 2t minus 3 minus 5t over 2t minus 3. Okay. Do I have common denominators? Yes. So let's write the whole thing over the common denominator, 2t minus 3. In the numerator, we have 3t minus 5t. And what is 3t minus 5t? Negative 2t all over 2t minus 3. Can I factor either of these things? No. Can I cancel anything? No. So we are done.
Is that like what we're going to have in the book or no? Is there even more?
These are similar. Example 4. Now we're getting trickier. Y squared over y plus 2 minus 4y plus 17 over y plus 2. Okay. Do I have common denominators? Yes. So we're going to write the whole thing over the common denominator y plus 2. And what's in the numerator? Y squared minus. And now, we need to keep 4y plus 17 in parentheses. Okay, because it's all in the numerator right here. So we're subtracting this whole thing. Okay, so that's minus parentheses 4y plus 17.
Wait, what?
Oh, you don't have to
Hold on. 4y plus 17 is all together in the numerator, so it's in parentheses. We have to keep it together. Okay? So, from adding and subtracting polynomials, what do I do with that negative? I distribute that negative, and we have to distribute it to both numbers. So what would I get in the numerator?
Negative 4y.
Y squared minus 4y at minus 17. Excellent.
Over y.
All over y plus 2. Okay. We are not done yet. Can I factor this guy?
Yeah.
What method would I use to factor? Diamond. So let's do the diamond method. I'm looking for two numbers that multiply to negative 17 and add up to negative 4. Nothing. So is this factorable?
2.
No. So that's your answer. Okay? If you cannot factor it, we can leave this as our answer.
Wait, so why?
Okay. 7y plus 8 minus y minus 1. Oh wait, 7y plus 8 over 4y plus 6. We all have common denominators here, sorry. Minus y minus 1 over 4y plus 6. No, it will not always have a common denominator. These right here do. Right after this, we're going to do not common denominators. Okay, so I do have common denominators, right? So we're going to rewrite the whole thing so that it's over a common denominator. So my common denominator is 4y plus 6. We have 7y plus 8 minus, in parentheses, y minus 1. I distribute that negative, very good. So I would have 7y plus 8 minus y plus 1. All of that over 4y plus 6. Now, is my numerator simplified?
Yeah.
No, I can
It's the greatest constant.
combine like terms first. 7y minus y, what does that give me? 6y. Positive 8 plus 1 plus 9. All over 4y plus 6.
They all have greatest common factor.
Oh my gosh, Jared, you are a genius. They both have greatest common factor. Carlos, you are also a genius. You are all geniuses. Okay, so geniuses. What's the GCF in the numerator?
3.
3. So if I factor out a 3,
It's gonna be 2y
it's going to be 2y
plus 3.
plus 3.
On the bottom.
And in the denominator, geniuses, what's the GCF?
2.
Very good, 2. So what's going to be left?
2y plus 2. Or 3.
2y plus 3. Okay, now what? Am I done? No. I can cancel what? 2y plus 3. So, ladies and gentlemen, what is my answer?
3 over 2.
Very good, 3 over 2. Example 6. H squared plus 1 over 2t squared minus 7 plus h over 2t squared minus 7. Do I have common denominators? Yes, I do. So I'm going to rewrite the whole thing over a common denominator. So that's going to be h squared plus 1 plus h all over 2t squared minus 7. Very good. Okay. Now, okay, Can I combine like terms here? No, because this one is h squared and this one is h. Okay, but this is not in the correct order, right? It has to go from biggest to smallest. So we're going to rewrite this as h squared plus h, plus 1 all over 2t squared minus 7. Can I factor this guy?
No.
Okay, what two numbers multiply to 1 and add to 1? 1 and 1 adds to 2. So does this factor? No. Does this guy factor? No. So this is my answer. Okay?